Hello Internet, welcome back to our shield shader. Well, it's a little bit more than a shader. In this video, we are going to be adding some impact waves. Effectively the idea here is we are going to add a sawtooth wave onto the impact, and then actually take advantage of this fourth number here to actually indicate the age of each impact. So it'll grow from 0 to 1, and then after that it will just disappear. So it'll represent the time, and then we can represent that in various ways to actually show how it should actually disintegrate or act on this. So that's going to require some changes to the shield controller, and we're also going to be adding another component to actually create these impacts, because we want them to appear and then expire as well. So that's what we're going to be working on. I think the first bit we want to do is actually going to be to modify the shader, which looks like this. This is picking up exactly where we left off with our previous video, the one where we were sending arrays into this shader. So what we're going to be doing is actually changing two things, I think. First we can probably drop the metallic and glossiness settings. We're not going to be using them, so might as well just reuse them for something useful. So I will get rid of those, and we can just set them to 0 for now. That should be fine. So this is going to be our impact size. Yeah. And so this is going to be a float, and it's going to represent the size of the impact at the maximum time. So at 0, the impact size is 0, and then over the course of its lifespan, it is going to grow to whatever size we specify here. So it's just a linear progression. I think linear is probably the easiest one for what we're doing now. We can obviously go back and change that if we need to, but it just makes the most sense here. So we're going to expose that down below, and then we need to actually access that. So how do we do that? Where do we get our position or our points? There we go. Okay. This. What we need to change, we're taking the distance and subtracting it from this 1. Instead of doing that, we're going to take the points W vector or W indice? W coordinate, and we are going to multiply that by our point size. Not our point size, by our impact size. And so previously 1 was giving our points that size of 1. Now that we have this, what should happen is it should go away. Because, well, is that what I expected? Ah, yes. Because our sphere is 0.5. So if I do 0.5, that should be right on the outside. And then like 0.1 should give us just a little bit of red right there. And then as we grow this, you can see it expand. And so this gives us a way to kind of fine tune the size of this. And if we want to change this a little bit more, what we can do is actually divide this size. Is this a good way? Yeah, this will work. Divide this size by the impact size. I'm considering if I want to do this. This will have a different effect than we may want, but what it means is like 0.1 should be a little bit more pronounced because it will be multiplied there. And so we should get stronger colors initially. And then as I move this out, it will slowly, once we get to numbers bigger than 1, the actual effect is lessened slightly. You won't really notice it here just because of the size of things, but hopefully it's a little bit apparent. Yeah, not really. So that's that. Effectively all it's doing. We should actually verify this in another way too, quick. So 0.5. What we want to also do is check this W. So as I change the W value from 0 to 1, it should grow, and it does. So that's working, which is fantastic. Now we have some hard, I guess it's not so much hard. I want this to be a, what's the word for it? I want this to be a saw wave, which, so there's 3 types of like standard waves. There's the classic like sine wave, which is just ups and downs. Then there's the saw wave, which is a spike with like a linear progression down or up. It can go in either way. And then there's the square wave, and that is kind of like spikes up and then spikes down. I'll put a picture here. This is a call out to editing me. Put in picture. Anyway, so those are the standard types of waves. I'm thinking it makes sense to have the most energy at the outside and kind of go out and then leave like a little trail. And we can do that with a saw. So we're going to do a fraction of 1 minus that. Is this what I want? Divided by the... I think this should work. Yeah, so I just want to invert this. Whoops. Ambiguous overload for a int, because I didn't mean to use an int there. Cool. That is not even close to what I wanted. Okay, it actually is. Huh. So that's where we're going to need that division, but you can actually see if I increase this, we actually get these like hard lines and then they grow and fade out. So that's sort of what we want, but not really like this. So instead, we should be able to, if I'm correct here, plug in the impact size as the other thing we're taking the fraction of. No. Dang. So let's divide this by the impact size. Which will, so what that's going to do is divide our maximum by the impact size. So hopefully it grows a little bit. And then I want to drop this down to like 0.25. So we should have a period of 0.25 units. Which should mean we should get 2 waves per iteration. So if I drop this to like 3-ish, it looks fairly close. I know that annoys people when I kind of like zoom around like that, but that's almost there. It's pretty close, and so that I'm happy with. It could be, we can probably validate that it's exactly what we want. But I don't know. It accomplishes the effect that I want, so I'm not particularly picky. So now that we have that, what we can also do is, do I want to do this? Yeah. Multiply the emissive strength by our, not like that. But I want to take this fraction that we have and multiply it by the points I dot W. So effectively, we're going to make it fade out over time. It's going to be a linear fade. So I spoke too soon. That is not a linear fade. Oh, that's because W is equal to 6. We want it equal to what? Oh, ha, ha, ha. That's wrong. Let's do this 1 minus that. So the time is going to go from 0 to 1, and so we want it to be 0 when it's at the maximum time. So there will be a linear progression to that fading out. And so as this grows towards 0, it fades out. And then goes blue, but that we don't care about that because we're not going to actually run into that case. But that's just the math being blue. So effectively, that's sort of the impact we're going to get is going to be a hit, and then it's going to spread out and go dark. And so we can increase the size of the hit by increasing the smoothness. And we can probably, if we want, we can actually add like some padding so we actually get the wave to go out. I kind of like the way this looks, so we'll probably stick with that for now. If you guys want to see a way to change that, or either come up with it yourself and kind of play around, it'll be a good excuse to do that, or we can look into it in another video. But this should be fine for now. So bang, you get hit, and then it like flashes out. So I think that's probably good for the shader. That should cover everything that we need to get done there. So I'm actually, just to test this and make sure we actually have the sum working correctly, I think let's do 0.33. So effectively a third of everything. I see nothing. Oh, wait, no, that should be correct. We may need to go on a bug hunt. Also, I'm going to delete the directional light. That'll make it way easier to tell where our impacts are. Yeah, this doesn't seem right to me. This doesn't seem right at all. We should so what's just to make sure I'm not going insane. That should work. It should be on the back now. Or yeah. So I would expect a red dot on the back, and we're not getting that. So I don't think this works. Why not? We sum up our emission and then do everything else. I don't think it's anything we just did. We actually never tested this. So I'm curious what might be causing it. Because it could be a whole bunch of things, unfortunately. We don't care about the projectile thing can go away. The point render can go away. That's all other stuff. And why doesn't it work? I don't know. Huh. So it has to be something with our shader has to be wrong, because our math looks fine there. And it's obviously working for 1. So let me check this bit. Just a bit. If I had 8 more, I would have expected that to get brighter if it was doing the sum wrong, but it doesn't appear to be the case. Well, actually, I would need to do this and then that, just so they're all duplicates. But that is not what is happening. Well, okay, I guess we're going on a bug hunt. That's annoying. What have I done wrong? I guess this is the part where me not knowing how to actually do this is coming back. Impact, all of that fun stuff. Let's do another. I know this function is getting way out of hand. But just for my own sanity, I want to stop it from ever becoming 0 or less than. There we go. So that must have been what was happening. We had some math that was causing it to cancel out, and so whatever our fraction was making it 0. So it's back now. Awesome. Which is why we didn't see that previously. So if we put these near one another, we should be able to see them add together, and we do. So this works. Now I want to write something to test this. So we're actually going to animate this shader a little bit and make something that will actually create these points and then age them. So what's a good way to do that? We cannot, it's actually a error in the shader if you set the array to have 0 indexes. So it's not possible for it to have no elements. So we're actually going to do a points dot if points dot length is less than or equal to 0, then do something otherwise, do the normal thing. So what we're going to actually end up doing is say set vector array, and this is going to be a little bit gross-ish, but we're actually just going to set it to a new vector4 array. Is that a good idea? No, let's do a private static read-only default empty vector. And we'll create a new vector4 array here with just one element, which will be a new vector4 of, say, 0, 0, 0, 0. And that shouldn't be a problem there because the count itself is going to be 0, so it's not actually going to draw that ever. It's just to avoid any shader errors, which you just don't want in your code that you're actually going to be using. So this way we can just use the default empty vector whenever there's an issue. And I think that handles that fairly cleanly. I don't know if there's a better way to do that, but that should at least clean that error up. Which means we're going to lose our test data if I do. Well, it's going to be fine. We're going to be generating way more. So this should load. Question mark. It's thinking about loading. Really thinking about it. I don't know why this takes so long. It's not. I've tested like antivirus. I've tested my hard drives. It's on a really fast SSD. So this shouldn't be a problem, but it seems to be some sort of like writing thing. I don't know why it takes so long, but it does. So here I am being annoyed and watching it's not even like a beach ball of death. What's the name for the new Windows waiting icon? Is it I don't know, the Cortana thinking ring. That's kind of lame. What do you call that? Eh. Well, it finally figured itself out. So let's set that to 0, and we don't get any errors, which previously we actually were, so this is good. Everything is fantastic. I don't want to save that yet. So let's create a shield attack simulator. And so what this is going to do is literally just, oops, attack a shield. So we're going to do a public float radius, which is going to be the radius of the attack. We're attacking a sphere, so that just makes sense. And we also, what else do we need? Public float shots per second, and a public float. I'm going to handle every part of this in this simulator for now, and then we're just going to take the calculated result and copy it over to our controller. You could get into an argument about whether you want like the aging and stuff to happen on the controller or not, but that's going to be up to whatever project you're working on and how you want to handle that. So we're not going to really cover that. That's on you. That's your design choice. So what else do we need? We need the radius shots per second. We're going to need a private float timer and a private list. Let's do a linked list. So we're going to use a linked list here because we're going to be adding and removing things constantly, and linked lists are just better for that. They can handle those kind of inserts in constant-ish, not really constant time, I guess, because we're going to not necessarily be pulling things from the start. But anyway, they should be able to handle this better. But then we just need it to be a vector 4. And these will be our projectiles. And finally, we need our shield controller. And so what I'm going to do is at the very end here, we're going to take our controller dot points and set it equal to our projectiles dot to array. And I don't have link, do I? I hate that it does that. That's so annoying. That like that giant Windows beep, especially when I have my volume up because I was listening to music or whatever, and then that goes off. Without other things, it gets really annoying. It gets your attention, I guess, but let's see here. Timer plus equals the time delta time, and then I'm actually going to do a while here because, well, we're going to do a while because if the timer is greater than, or if we're firing a lot of shots and they have a really short duration, it's possible for, at a slow frame rate, it's possible for multiple shots to occur in a single frame. And so we'd never actually catch up, or we'd just be behind. So actually if we do while timer is greater than the shots per second, or not shots per second, shot wait, shot time, shot cooldown. The naming struggle is real. All right. So while the timer is greater than the shot cooldown, we're going to do timer minus equals the shot cooldown and just subtract from that. This prevents us from getting any additional floating points, and it will also increase our accuracy. So if, for example, let's say we take 5 frames, or yeah, like 5-6 frames to actually count up to that, it's possible that it actually only took us like 5.5 frames to count up to that. And at that point, we'd actually be losing like half of a frame every single shot. If we rolled it back to 0, like we could do, by doing that, we actually lose that frame. Whereas if we just do the subtraction, we actually persist it over time. So over time, it should be more accurate. Whether that matters or not, I'm not really sure. But, you know, why not? So what we're going to do is do a projectiles.add last. And we're going to add a, not this, because we're going to get a random on unit sphere, which is going to be a vector 3. So this is going to be the point that we're spawning it at. And I'm going to multiply this by the radius, just so we have that. And then part of the issue is then we have to actually turn that into a vector 4. Because we need point x, point y, and point z. But we also need 0 for the initial time. And so that should capture our point. It should capture the time that we're going to send. And then the final bit that we need to actually send over, public float projectile life. Yeah, that makes sense. So what we're going to do is then for each projectile in our projectiles, we're actually going to increase their life, which this may not work. Projectiles.w plus equals time dot delta time divided by our projectile life. So the projectile life defines how many seconds it's going to stay alive. So if we do 5, we're counting from 0 to 1, so we actually want to divide by 5 and actually take a fifth of a whatever the current time was, and that will actually get us up to 1 in 5 seconds. The problem we're running into is this is a struct, which means we can't modify it during a for each. That's not valid. What's a good way to do that? Is there a good way to do that? Not really. 'Cause, I mean, yeah, no, not really. I don't think this is valid. That's not gonna work. You can't do that. That's a really bad idea. Let's see here. So there's a number of ways we could do this. And I'm starting to think using a list might make more sense. So if I do vector 4 projectiles array, initialize that so projectiles equals a new vector 4 array of say 100. Is that a good idea? This seems like an even stupider idea. I'm trying to figure out a good way to handle the modification of that W vector, or that W argument, without having to do anything crazy. And there's ways to do it, and I still haven't decided on the best way to do it. This may be one of them. So we're going to add to our list. We're changing it to a list, which is going to allow us to actually increment over these. This probably isn't the best idea for the way to do this, because effectively what we're going to do is say int I equals 0 while I is less than the projectiles. Then increment I and do everything on I, which means we're effectively going projectiles I dot W because it's not a variable, right? Oh. We would do something like this. Vector 4. This is effectively just me trying to move it past this point. This has been something that I've constantly struggled with, and I still don't know the best solution. If you guys have a really good idea for how to handle these kind of errors or situations where you have where you're modifying a struct, besides putting it in some sort of container, which is possible. Like I could literally just go create a class and say some sort of container that has a vector 4 in it. Then it's super easy because then I can just take that vector and modify it. But without that, it's really not, I'm not sure it makes much sense. But this way, our garbage collector is going to hate us, but we're going to be on Unity, or we're going to be on C# 4.6, which has a generational garbage collector, which matters less. Still matters. This is not a great idea, but it's not as bad. Yeah, it's still pretty bad. I may need to rethink this. I think we can come up with a way where we can handle this incrementing in this shader. And if we can do that, then we actually don't need to modify them. We just need to add them and then remove them at the end. Whereas this requires us to constantly monitor and remove things. So, since we're going on down this whole really bad ideas, let's do projectiles equals a new, or not that, projectiles dot where. This is a really bad idea. Projectile, where the projectile dot w is less than or equal to 1. And I want this to list. So this is going to create a new list every single frame. That seems like a really bad idea. And so if we're going to do that, hold on. I'm going to mark this as a to-do. But what we can do is actually, I can select. Select is sort of a transformation of values. And so by selecting it like this, we can actually drop a lot of this more, I don't know, array-like stuff, and actually just increment that. And we're just going to pass down that. It really doesn't like that because we forgot a parenthesis, but then we get something that looks like this, which is going to take our current projectiles, transform them so that they have a incremented W, and then only to select the ones that have W less than or equal to 1. So only the ones that are still valid. If they're not valid anymore, they just get dropped from the list. It's effectively deleting the ones that aren't valid. And then after that, we convert it to an array as well. So we create a whole bunch of new vectors, a new list for those vectors, and an array of those vectors every frame. That is a terrible idea. But this is sort of designed just to test the dynamic nature of this. So hopefully people don't get too mad that I did this, because I think we can all be sad and a little bit amused. Alright, projectile life, we'll say just 1 for now. Shot cooldown, we'll do 10 a second and 0.5. So, if we move our camera to something reasonable and move it down, let's do 1, 1, and 1. And then 45 and negative 45. So it's sort of centered-ish. Okay, that didn't really work. Centered-ish. There we go. So now I should be able to run this, and our simulator should... That's not entirely what I had in mind. Why do we keep creating things? Huh. That's weird. That's not really what I had anticipated. I wouldn't expect... It seems to be rearranging them, and that's not something that I expect from this. Granted, there's no guarantee that it isn't going to do that. But this seems weird that it would be. While timer is greater than the shot cooldown, subtract the timer, create a new point, and add the projectile. So that's going to create our new bullets. And then for everyone we create, we are going to keep their X, Y, and Z. So that's not getting moved. And then increment their life. So this, since we have projectile life equal to 1, this is literally just projectile.w plus the time delta. Where projectile... We've run into a number of issues here, and I'm not sure how to fix this one. Because we're effectively just incrementing our timer. That's all that's happening here. And let's see here. Debug, log, new projectile. So what was confusing is the first one worked. And then all the other ones didn't. And that made way less sense to me. So, if I start this, I would expect, yeah, that. We're getting about 10 per second. So then, So then why? See, there our W is really small. Okay. We're gonna tune this down. Shot cooldown point. Oh crap. I just crashed Unity because I typed a 0. Whoops. I will be right back. That is death. Alright, I think we're back. I had to recreate the scene because I didn't save the scene and it crashed. So, this is where we're at. And I have changed the shot cooldown to 1. So hopefully when I hit this, it looks a little bit more real. And it does. Interesting. 0.5. Ooh, that is destroying Unity's UI. So that's what's happening. It's only taking the first one. Didn't we just encounter that earlier? But it doesn't appear to be completely taking everything. We're losing some of them, which would explain it, because as we remove things from our list, they'll move towards the top or towards the front of the list. So only the new or the old projectile hits are going to be shown that way. Okay, that directional light makes it harder to see. But so what's happening is as this gets lower and lower, it's only taking the latest projectile. So what is causing that? Because we showed that you could have two overlapping things. What? What is going on? Why does it work now? I mean, cool, it works now, but what? Why? How? When? What? I didn't do anything. I'm super confused. But anyway, that's what I was going for. So it looks like impacts. It kind of looks like, shoot, there's, what's the name of the game? Plague Inc. I think that's what I'm thinking of, where they have the infection or whatever and it pings. Sort of a shader like that. I don't know. Eventually this is going to change a lot. I'm planning on adding a refraction shader or something on top of this, and then having this affect the normals on that, so it looks like it literally just pushes things out of the way and you can actually like see a ripple go across the world. I think that'll be really cool. And maybe there will be some like energy emission or something. This is not the final product. This is just a demo of how to do this. This was supposed to be super short, and I've been recording for 50 minutes now. So that worked well. But I don't know. This is where I wanted to be. And I have no idea how we got here. So that's nifty. What? I literally can't even undo. What? All I did was retype length and save. And then it worked. I don't get it, but it works. So yay. I think that's gonna take, I'm gonna need to go look at that, because I don't understand that. We'll cover, I'll try to figure out what happened for the next video, but I'm super confused right now. So this is sort of where I wanted to get, where we have this effect. Next we'll be making this transparent and actually getting it to look like a shield that you could actually use, because right now it's just a giant circle. But yeah, that's sort of the steps. I don't know, it looks cool. So we'll leave this here, and if you guys have any feedback or suggestions for me, anything you want to see, let me know in the comments and we can definitely get to that. Other than that though, thanks for watching, and I will see you guys in the next video. So till then, see you, internet.